Hello everyone, good evening. I hope all of you are good and I am also fine. So today I will take another class from chemistry, that is class 11. The chapter is thermodynamics, that is physical chemistry, okay? And this will help me for basically for NEET, JEE and CUT entrance exam, okay? So our first question is like that. What is the change in the energy of the system if 500 calorie of heat, this one is heat, 500 calorie of heat are added to the system and surrounded system, and system does at the kilo of work, that is 250 calorie of work on the surroundings, okay? So what is the change in internal energy, we have to find out. So what is given here? So given del Q is equal to 500 calorie, work done on the system is what? W equal to minus 350 calorie. So we know that internal energy U equal to del Q plus del W, okay? So 500 minus 350 is equal to 150 plus 150 calorie will be internal energy of the system, okay? The change in internal energy or change in energy of the system. So this one is the change in energy of the system. So which option is correct, sir? Option B is the correct answer. Option B is the correct answer here, okay? Got my pen? Okay, let me explain. This is the from first law of thermodynamics. We know that from first law of thermodynamics is what? Del U is equal to del Q plus del W. This is the first law of thermodynamics, and from that we find it, okay? So move on the next question. So students, our next question, that is question number 2, is like that. In an adiabatic process, no transfer of heat takes place between the system and the surroundings. So in adiabatic system, no transfer of heat takes place between system and surroundings. That is del Q is what? 0. In adiabatic system, del Q is 0 for adiabatic system, okay? Adiabatic system, del Q is 0. Now choose the correct option for the free expansion of an ideal gas. So for free expansion of an ideal gas, so free expansion of an ideal gas, what? W is 0. W or del W is equal to 0. Okay. Now for ideal gas, so for ideal gas we can say now for ideal gas, okay, we can for ideal gas what? Del T is equal to 0. Okay. Why? Look at here, from first law second thermodynamics, we know that del U is equal to del W plus del Q. So this one is 0 and this one is 0. So this one is 0. So internal energy 0 means temperature is constant, because temperature, internal energy directly proportional to temperature, okay? So that is internal energy is constant. So internal energy is constant. So we know that internal energy is directly proportional to temperature of the system, okay? So internal energy is directly proportional to temperature of the system. From that we can say also if del U equal to 0, then we can say del T equal to 0, okay? Or for ideal gas, del T always 0, okay? Change in temperature is 0. And which option is correct? Which option matching here? Q is 0. No, this one is not, because Q not equal to 0. Q is 0 here. This will also not. And C is Q equal to 0, del T is equal to 0. So option C is the correct answer. So option C is the correct answer. So look at here. This is also not, okay? Q is 0, but del T not equal to 0. This is also not, okay? So what is the question here? In an adiabatic process, no transfer of heat takes place between the system and the surroundings. Okay, so choose the correct option for expansion of an ideal gas under the adiabatic condition from the following. Okay, so for adiabatic process, del Q equal to 0. For free expansion of an ideal gas, del W equal to 0, that is work done is 0. And for ideal gas, del T equal to 0, we can say. Or in other cases, or we may write del A equal to del W plus del Q, 0 plus 0, that is 0. So that means internal energy is what? Internal energy constant. So if internal energy is constant, then we can say temperature is constant, because internal energy is directly proportional to temperature of the system. Okay, so our option, which option will be correct? Option C will be correct. And this question is came in AIMS 2018. This question came in AIMS 2018. Okay, this question came in AIMS 2018. So we move on the next question. Okay, so let's go. Hello everyone, our next question. Okay, so our next question is came in NEET 2019. Okay, so this one came in 2019 NEET. The question is like that: reversible expansion of an ideal gas under isothermal and adiabatic condition are as shown in the figure. This is the figure, this one is pressure, this one is volume. So this graph represent isothermal expansion. Okay, isothermal, that is A to B. A to B is isothermal expansion and S to C is adiabatic expansion. Okay, the coordinate is PA, PB and TA. Here is PB, PA, PB, BB and TB. Or here is PC, BC and TC. Okay, these are the thermodynamic variables in 3 different points. Now the question is, which of the following option is not correct? That is, among 4 options, 1 option will be wrong and the other remaining 3 options will be correct. So the wrong option we have to calculate it. So from first law, look at here. From first law of thermodynamics, we know that del U is equal to, or U equal to Q plus W. Okay, so internal energy is equal to heat plus work done. Okay, now for adiabatic expansion, what? Q is equal to 0. So therefore we can say U equal to W. Fine. Under expansion adiabatic condition. Okay, reversible expansion. For the expansion of gas, what we have? For the expansion of gas, we have work done is negative. Okay, you have to remember this one. For the expansion of gas, of ideal gas, work done is negative. Now come here. If work done is negative, then we can say from equation 1, we can say what? We can say that is U is negative, that is internal energy is negative. Okay, now come at here. We know that internal energy is what? Internal energy is N CB del T. Internal energy is NCB del T, the formula of internal energy. Okay, so we can say therefore NCB del T is less than 0. So this one is constant, so del T will be less than 0. So if del T less than 0, then we can say this one is isothermal. We know that in isothermal condition always temperature remains constant. So here this one is correct. Okay, and W isothermal is work done is always greater than W adiabatic expansion. This one also correct. So here if you take this part, it will be del T minus del A is less than 0. So del Tc less than del A. So the condition is here, temperature of at point A is must be greater than that the temperature at point C, but here is reverse direction. Okay, here is reverse direction. So this is the correct answer. That means this is the wrong answer. Okay, and which option will be correct? Here option D will be the correct answer. Okay, so let me explain again in 10 seconds. For a reversible process of an ideal gas, isothermal, a reversible isothermal and adiabatic condition are shown in figure. This one is adiabatic expansion, this one is isothermal expansion. Okay, which option is not correct, we have to find out. So for first law, from first law of thermodynamics, we know that U equal to Q plus W. Okay, for adiabatic expansion, we know that Q equal to 0. If Q equal to 0, then W equal to U equal to W. For expansion of gas, we know that work done is less than 0, negative. So if work done less than 0, that from equation 1 we can say U is less than 0. Fine. U, internal energy is, formula of internal energy is U equal to NCB del T. Now this part is constant, so this part less than 0, so del T less than 0. So del T is TA, Tc minus TA. If I take Tc minus TA less than 0 for adiabatic expansion, temperature is different. So Tc less than TA, that is temperature of A at point A is greater than the temperature at point C. So which option is correct here? Option D is the correct option. But actually this one is the wrong answer, but option is correct here. Okay. So this question is came in NEET 2019. So move on the next question. Okay, move on the next question. So our next question, that is question number 3. In an adiabatic condition, okay, in an adiabatic condition, 2 moles of CO2 gas expand at 300 K. 2 moles of CO2 gas at 300 K is expanded, okay, such that its volume becomes 27 times. Expanded, okay, such that its volume becomes 200 times. So here B2 is equal to 27 B1 and N is 2 moles. And temperature T1 is 300 K. So T2 is what we have to find out. Now we know that T2 by T1 is equal to B1 by B2 whole to the power gamma. So gamma is what? 1.33. So T2 by T1 is equal to B1, this one is 27 B1 whole to the power gamma. Gamma is what? 1.33. That is gamma minus 1. Formula is gamma minus 1, so it will become 1.33 minus 1. This one cancel. So T2 by T1 is equal to 1 by 27. It will become, if you do LCM here, it will become 1 by 3. There is 0.3. Okay, 0.33 means 1 by 3. It will become 1 by 27 into 1 by 3. Now come here. So T2 by T1 is equal to 1 by 3 to the power 3 whole to the power 1 by 3. So this one will cancel. So T2 by T1 is equal to 1 by 3. So T2 equal to T1 by 3. T1 is 300 by 3. It will be 100 K. Now T2 is less than T1. It means gas is cooling. Okay. It means gas is cooling due to what? Expansion. Okay, and in adiabatic process Q is 0. So therefore del U equal to W plus Q. So del U is equal to W is Q is 0. So it will be W. But in case of expansion, W is negative. For expansion, W is negative. Therefore del U is negative. Okay, del U is negative. here n is 1. Okay, here n is 1. N is 1. So after that we can write del u is equal to minus del w, or del w is equal to minus del u. So del u is n cb del t. N is 1, cb is what? Specific heat 6, and del t is 300 minus 100. So minus 100 minus 300, it will be minus 200. So 1200 calorie. So plus 1200 calorie will be the answer. So plus 1200 calorie will be the answer. So work done is what? This one. Got my point? So let me explain again. In an adiabatic condition, 1 mole of gas CO2 gas is at 300 K is expanded such that its volume bigger 27 times. That is B2 is 27 of B1, gamma is this one 1.33, and CB is given here. CB is what? 6 calorie, and it's 1 mole. T1 is 300 K, T2 we have to find out. So from the adiabatic relation, this one is from adiabatic relation. Adiabatic relation. Okay, there are 3 relations are there. This one is one of them. Okay, so T2 by T1 equal to B1 by B2. Sorry, T2 by T1 is equal to B1 by B2, gamma to the power minus 1. Now I put all the values. After simulation, what becomes? T2 by T1 is equal to 1 by 3. That is T2 equal to T1 by 3. That is T1 is what? T1 is 300. So 300 by 3, that is 100 K. Now since T2 less than T1, it means gas is cooling during expansion. Okay, in an adiabatic process we know that Q is 0, and if during expansion, if gases expand, then in that case work done is 0. So from that work done is negative. Okay, if gases expand, then work done is negative. If work done is negative, then internal energy also negative. So work done is equal to minus del U. So the formula of internal energy is n cb del t. So n is 1, cb is 6, and del t is T2 minus T1. T2 is 100, T1 is 300. So 100 minus 300 equal to minus 200. So after simplification, what comes? 1200 calorie is came. So which option is correct here? Option D is the correct answer. Option D is the correct answer. Got my point? Option D is the correct answer here. Option D is the correct answer. So we move on the next question. That is question number 5. Okay, now we move on the next question, question number 5. So students, our next question, that is question number 5. Okay, this is the last question of the lecture. This is lecture number thermodynamics part. This is part 03. Okay, this one is part 03, lecture number 3. So this is the last question of the lecture. The question is like that. In this question is came in JEE. Okay, the change in internal energy we have to find out when 4 kilojoule of work is done on the system. So note here, this one is 4 kilojoule. Okay, and 1 kilojoule of heat is given out. So when work is done on the system, then work done is what? Positive. Okay, so here W is equal to plus 4 kilojoule. What happened? When work is done on the system, in that case what happened? In that case W is work done is positive. So W equal to plus 4 kilojoule. Now 1 kilojoule of heat is given out. So when heat is given out, then heat is negative. Okay, heat in that case is negative. When heat is given out, in that case heat is negative. So Q will be minus 1 kilojoule. Okay, so now from first law of thermodynamics, what we have? We have del U equal to W plus Q. So that is 4 minus 1, that is plus 3. So plus 3 kilojoule will be the change in internal energy. Okay, So which option is correct? Option D is the correct answer. Option D is the correct answer. Got my point? So here what is given? Given change in internal energy when 4 kilojoule of work is done on the system and 1 kilojoule of heat is given out by the system. Then 4 option is given. Which option is correct? We have to find out. Okay. Now when work is done on the system, then work done is positive. There is W equal to plus kilojoule, and when heat is given out, then heat will be negative. So Q will be minus 1 kilojoule. So we know that from the first law of thermodynamics, internal energy, change in internal energy equal to work done plus heat. So I just put the value W and Q is what? After that, the final answer, there is plus 3 kilojoules came out. So which option is correct here? Option D is the correct answer. Okay. So I hope these 5 questions will help you to understand or to revise or to prepare for the NEET exam, okay, or JEE advanced exam. Okay. So thank you for watching. Have a nice day. Take care.